get started. Thanks everybody for joining last session of the day. The title is a little different than what you saw on the door. The content is the same, but this title is just a little more amusing. So we're going to talk. It's too bad it's a few days after Halloween. This is a story of fear and loathing, which seems appropriate for Halloween. I want to start with just kind of a little bit of orientation or context. So some of you may have heard of Eclipse Che. Eclipse Che is a fairly new project within the Eclipse Foundation. It came about last year, actually about this time. It's a browser-based IDE, a RESTful workspace server for developer workspaces. It's got plugin extensions kind of similar to the Eclipse desktop IDE, so similar concept, different technology. And then it's got an SDK which allows you to kind of create these plugins and assemblies. Now I'm from Codenvy, and Codenvy makes on-demand developer workspaces kind of built on Che. We had a series of extensions to make them more replicable, more collaborative, and constraint-free. So what I'm going to be showing you today is Codenvy, but the kind of heart of it is Eclipse Che. All right, some Eclipse Che metrics. So Codenvy is a strategic member of the Eclipse Foundation, and the Eclipse Che project is seeing over 250 basic contributions per month from both Codenvy and some of the other organizations like those on the bottom that you see who are contributing to the project. Within our 49-person team at Codenvy, just kind of speaking for us, we've contributed over 16,000 contributions to various open source projects, not just Che, but a lot of other things as well. So let's get to the story. So this story is really about Codenvy as a company. It's about the process that we followed, the process that we follow now, and a little bit about the tool changes that we made in the intro. And it's a story of fear and loathing because basically it kind of started about 2 years ago with a management team that was filled with fear about every release and about how we were going to get features out into the market for our customers, and a set of developers who were filled with unhappiness and loathing because things just weren't working properly. So this may or may not be familiar to some of your organizations, but we were agile. We were trying to get releases out fairly frequently and used continuous integration and had a fairly constant release cycle. The challenge was that the kind of consistency, the reliability, things like that were not there. So developers were often holding on to feature branches for a very long time. In many cases, the merges would create conflicts. Those conflicts would take time to resolve, sometimes days. Build, as a result of the product, was often broken until very close to the release, making it difficult for us to get feedback. It was an extremely stressful time for everybody. You can imagine that as this is happening, of course, management is kind of standing over the developers like this, and developers like nothing better than management doing that. So the end result was that we were working very slowly, and we were missing opportunities. And this was obviously a serious problem for our business. Now, when we sat down together as a management team, as a development team, and looked at what we were doing, we noticed that we were doing agile, but that there was a disconnect between our local host development and our continuous integration and more continuous delivery processes. So we said, okay, what would be needed for us to move from being just agile but disconnected to actually continuous development straight through continuous integration and delivery? What would that look like? We would obviously have to shorten the time from the moment the first code was touched by a developer until it was released. That was kind of the macro goal. And then the way we got to that is we realized that developers had different branching policies and different behaviors with those branches. That there was sometimes confusion about which branches the feature development should be done on when someone new jumped onto a feature, or jumped onto the project, or jumped onto the team. There was kind of an inconsistent toolkit. Some of it was consistent, other parts weren't. The workflow, again, similarly, some of it was consistent, some of it not. Some of it was consistent within a team, but not between teams. And last, and perhaps most importantly to management, is we needed to have a way to get feedback in earlier into the cycle. which the developers wanted as well. They wanted to be able to get useful feedback. And so what was happening was that we would be so close to the end of release, and then management would see it, we would have a bunch of feedback, and that's frustrating for a developer because you've spent so long getting to a certain space. It would have been better to have that context feedback earlier in the cycle. So where we needed to get to was this concept of an on-demand workspace that could be actually connected in to the rest of the continuous process. So that's what I'm going to show you. In this particular demo, I'm going to use, as I said, Codenvy, connected to Jira, connected to GitHub, connected to Jenkins. That's the tool set we use. It's a fairly common tool set, but you could sub in other issue management, other repos, other CI. It conceptually work the same, just the plugins would be different. All right, so this is our Jira system, and you'll notice it looks pretty standard. What we've added is this new field, Codenvy factory link. The Codenvy factory you can think of as kind of a template or a recipe around the whole developer workspace. That means everything that's required to configure the IDE, connect to the source code repo, including the branch, the commit ID if necessary, or just to the head. It's about the structuring of the compile and build environment required for that particular project, which is going to be different, obviously, if it's JavaScript or Java or C or whatever have you. And then the recipe for the run environment needed to debug. And this is all pre-CI. This is all what today most developers do on their local host when they're doing that development before it gets shipped off to the CI. So what we did is we wrapped all of that information, all that configuration into this concept of a factory, this factory recipe. And then that gets triggered through a URL. That URL you could put anywhere. In our case, the developers always start work in Jira, so it makes sense for us to put that URL in Jira. You could put it in the wiki, whatever you want. So now, when a developer comes in to start working on a feature, we want always for the feature branch to be created at that moment with the latest commits from master as a new feature branch. We want, as a result, that this factory be synced to and actually trigger the creation of that feature branch. So that anyone who then later comes into this Jira issue to work on this feature, perhaps the developer needs help, if they click on that link, they should jump right to that feature branch, right to the latest commits. So there's no thinking about what branch should I be on, am I on the right branch, any of that stuff. So this kind of all automates that. So when I click on this, now, still within the browser, obviously, I'm going to load up Codenvy. You're going to see it's going to pull the source code in from the repo, including from the correct branch. I'll show you that in a second. Now let's put this part away for a second. And you see I've got all my source files, a bunch of JS files. As this is pulled in, the project has a type. In this case, this is a JavaScript project, and it's built with Bower. So that's the type for this particular project, and that's set, obviously, by the code in the repo. When we see that, what we're able to do is for each individual developer who clicks on one of those links, we create a Docker machine. So Docker, for those who don't know, is a container technology, kind of like a VM, but very lightweight. So we give them their own isolated Docker container with Bower, and we inject the source code inside and build it automatically. So within a couple seconds of my having clicked that link, again, I don't have to download anything, I don't need to install anything. It has pulled down the source code and built it so that I know that I'm kind of doing my development on a solid foundation. Now, there's also, in here, a Dockerfile. This Dockerfile represents the running or debugging environment that I, as a developer, will use. So code is built now, and I can even go ahead and run it immediately to see kind of what the current state is of the code on that branch. And again, as development happens, as commits are made, behind the scenes, that Codenvy factory is constantly updated to point to the latest commit point on the branch. So it's always synced with head, in other words. So that's actually something that's happened already. This is what we call our RunnerPanel. So this has now gone and created another Docker container isolated to me, using that recipe, so that any developer clicks on that will get a consistent environment, but that environment will be, again, isolated for them. You can see the Docker commands have gone through, my container has been built, the app is run, and I can click this link at the bottom and actually now, in another browser tab, look at my environment. If this was a thick client application or a desktop application, I would get the UI through the WebSockets. In this case, it's a web app. You can see we have some problems. I mean, we're doing feature branch development. I would expect some problems. But it means I can kind of cruise through here as a developer or as a PM or docs or anyone. So one of the kind of nice side benefits of this is that before we institute this, the first thing that Steven, our PM, who happens to be sitting right there, would do in the morning is get in and start on IM or email, pinging each of the developers working on the projects he cared about for that release. How's it coming? Is this green now instead of blue? Are you showing dead runners, not just live runners? When am I going to see this feature? Is this thing ready? And as a developer, when you're kind of in the flow, those interruptions for status are frustrating. They kind of break you out of what you're thinking about. You go and respond to them, and it takes you some time to get back into that development flow that you were in. The nice thing is that now the PM, Steven, doesn't need to do that. He just goes into Jira, clicks the link, runs the environment. It's already synced to the feature branch. It's synced to the latest commits. It shows him exactly what is there, what's done. So he just flips around in this, looking for the things that he likes or doesn't like. Oh look, they've actually started populating the projects now. Oh great, I didn't think that would be done until tomorrow. That's awesome, they're ahead of schedule there. So he doesn't need to email anybody. And if there's something is wrong, or that he doesn't like, then he'll ping the developer, but now they can have a conversation about something the developer is working on at that minute. Not something they worked on a week ago, or 2 weeks ago, or 2 months ago, or 6 months ago. It's at that minute. So that's a very useful dialogue. The developer is in there, they're working on this. Why does this have a shadow? I thought it was supposed to be flat. Oh, well, I tried it flat, but it looked weird. You couldn't see the lines, and it was really confusing. Are you sure a shadow isn't okay? This is a good dialogue for a PM and developer to have at that moment. So, now we've gone through, we've done the editing. I don't have a ton of time in this particular talk. So for the editing side, you're way better off to visit our booth, which is just over there. And we can show you the Java editing in Eclipse Che, which is exactly the same as in Codenvy because we use Eclipse Che. And they can kind of play around with the refactoring and all the code assist and all that fun stuff. But let's say I've gone ahead, I've talked with Steven, and I think this feature is ready. What some of our customers do, which is actually extremely cool, is they package up these environments with multiple running stacks. So you can see a bunch here. Okay, this is the one that's kind of the default for the project, and then here's some other options. What one of the customers does that I really like is they include a minimum of 2 environments with every one of these factory workspaces. One of them is what they call a hack environment, which would be something lightweight. So maybe it's a web app in Java, and it's Tomcat and MySQL, a little minimum amount of data, just enough so the developer can work and figure out what's working, what's not working. But then they create a production replica. And that production replica could be a lot bigger. In their case, it's like 64 gigs of RAM it takes to run the various requirements environment for this production app. This laptop does not have 64 gigs of RAM. I don't really want to buy every laptop with 64 gigs of RAM. So the beautiful thing is, again, the way this works, there's an isolated Docker container running in a central private cloud behind the firewall, which can have 64 gigs of RAM. It can run that production replica. So as a developer, before I check into CI, at that moment, I can run even Selenium tests against a production replica environment for this new feature and get some confidence that my code is going to pass. They actually make that a requirement to this particular company before they merge back into master, that they show that those kind of tests have been run against that kind of environment. So it can really reduce kind of broken builds later on. But let's say I've done that, and now I issue my PR, I merge it's accepted, branch gets merged back in, it goes to my CI. And let's say that there's a bit of a problem. So sometimes we get these build failures in our CI. No one really likes them. In this case, once again, similar to what we do in Jira, we add another one of these workspaces here. Now these workspaces are auto-generated by Codenvy based on that project template. So no one had to do any work here. What we did is we have a little plugin in Jenkins. It sees the build failure. It sees the repo. It sees the branch. It sees the commit where the build broke. And we can even parse the output and look for, here we go, non-parsable pom.xml. So we go through, rip through that and say, all right, let's create a factory at that moment specific to this build failure and pre-open that particular file or files which broke the build. Obviously, not all build failures will have specific files. You can't always do that. But in the event that they do, it's a really nice kind of shortcut. So here we go. We pulled in the same project. And there's the Polym XML already open. You can see, obviously, probably shouldn't have commented out the closing parent tag. That's going to break the POM. It's going to break the build. That's a very simple one, clearly. But conceptually, this kind of thing is a great way to kind of help automate some of these processes that, as developers, you go through every day. It just takes a little bit of that load off. All right. So when we started this, I think we all felt like this would make a difference. And we are, I think, all universally surprised by the degree to which this type of automation makes a big difference. Going from 2 software releases to 20. That's a 10x improvement. Obviously, that's pretty huge. And a lot of that was that some of these things began to click a lot more smoothly. We didn't get the same delays. We didn't get the same number of broken builds. We didn't get the same number of difficult merge conflicts. And as a result, smoother development means smoother integration, means smoother releases. This one is especially surprising, though. I think the code commits per engineer within the week had gone from being 5 per week to 30 per week. Now, certainly different weeks can be different. Maybe there's a small amount of variance there, but nevertheless, a 6x increase, a bunch of that is the reduction of the time it takes to otherwise rebuild your local environment as you change branches or projects or teams. Instead, this is all replaced by that kind of instant availability of the developer workspace. And the last one that was especially important, I think, to us was that we kind of went from not being able to allow customers to give feedback kind of until an official beta release had been made and pushed out there. Instead, we can actually take that URL, and as long as we give the customer the appropriate permissions, we can post that externally. That customer can actually now look at code in development. So we're lucky we have some technical advisors. They have very strong feelings and good guidance on certain types of features, things they care deeply about. And so rather than go through a whole cycle, get to the beta and have them go, yeah, no, it's okay. It was not really what I was thinking of. Like, it would have been way better if it had done this, this, and this, or if it looked like that, that, and that. Instead, you do that as the developer is developing. You get that feedback faster, smoother, and when you can action on it in a more efficient way. What also surprised us was, in the context of our business, we were looking at the usage of our particular SaaS product. And what we saw was a 400% lift in usage as we began getting features out faster. But not just faster, that they were on target more often in kind of V1. They didn't require the V2, V3, V4 revs the same way older features had. Because that feedback now was coming in early enough that it was shaping that feature from the beginning, allowing it to hit what it needed to hit. So, while we still have a few minutes of time, I wanted to describe a little bit about the architecture, kind of how all this works. Sometimes it's a little bit difficult to conceptualize. So Eclipse Che is a little different than your desktop IDE. We have a kernel. We have basically a RESTful workspace server and a cross-browser IDE. So what happens when you start up Che is that the workspace server starts first. It kind of runs as a web app in something like Tomcat. This could be on your machine. It could be on a central server, whatever you want. The browser IDE components are pulled from the workspace server, served up in your browser. You saw that's where the IDE was. As I said, you can visit our booth and we can show you more about the features of that IDE. And then, as you also saw, the creation of build environments, run environments, debug environments happens from the workspace server into a machine API, a command API, which allows us to send specific commands to multiple machines, get some kind of efficiencies there as well. Now, this is all open source. It was all designed to kind of mimic the plugin extension framework that Eclipse RCP uses. So just like in that, you can create these custom plugins and change, augment, add to the environments, the machine API, the workspace server. We even have customers like SAP who are taking all of this part and then creating a wholly custom web IDE on top. In the case of SAP, of course, they want to build something that is familiar to an SAP development audience. So our web IDE wasn't quite right for them. They wanted to build something for themselves. They just call into the APIs, the same ones we use. They have the same performance, the same feel, the same functionality, everything, but with a custom look and feel that they want and like. Now, Codenvy basically takes that kind of heart of Eclipse Che, as I call it, and then adds kind of enterprisey features on top of it. Automation, which is that factory and toolchain integration that you saw here. We add multi-tenancy, we add an elastic Docker machine pool, we add HA, all these things so that you can kind of grow this out as large as you want. At our Codenvy SaaS, we have over 150,000 users, over 400,000 projects. Obviously, we have to be able to scale quite large. We also have very large customers. Management, things like central administration. We've got analytics that shows you how environments are being used, what languages are being used, how developers are interacting with the repo, how they're interacting with the workspace. And then distribution via either codenvy.com for SaaS, which is really ideally suited more for individuals and very small teams, or on-prem, where the majority of our customers take, which is basically the same software that runs our public cloud, but now installable in their data center, behind the firewall, or in their own private cloud, so that they can integrate it with their tool chain. They can control the security of it for their organization. So that's what folks like Fidelity or Deutsche Bank and others are interested in. And the last is the white label, which is taking this and then creating something custom around it. That's the work we're doing with SAP, it's the work we're doing with Red Hat, and a number of others. So, Codenvy team-based developer workspaces really are about opening that continuous delivery process to everyone right from the beginning of development, as opposed to having it start, as in most organizations, with the point at which CI starts. All right. That worked out reasonably well. We've got about 10 minutes for questions, which is kind of what I was hoping for. Anyone? Bludgeoned you to death? Yes.
How are you managing the distribution of Docker containers in this scaling Docker cluster?
Yes, good point. Good question. So it's actually interesting. A lot of people kind of ask, well, do you use this or that, Kubernetes or whatever have you? The answer is, strangely, perhaps, at first, we built our own mechanism to provision, deprovision, replicate, and scale these Docker containers. And at first that might seem a little crazy. It's not, because unlike everything else that was out there, which was really production facing, and was built to be HA, built to be, have all these extra features that you need in production, what we needed was to be able to spin up these Docker containers very fast, deprovision them very fast for developers. A developer is used to working on their local machine and expects instant response. But they don't care about HA. So what if my, Docker run node crashes because I, put my machine to sleep or whatever? It doesn't really matter. I can start another one. But you saw how fast those started up, how fast they stopped. And that was really why we created our own, so we could really focus just on near zero latency for those Docker containers. In our next gen solution, this was actually our current solution. In our next gen solution, which is at our booth, it gets even better because we're actually pre-starting some of these containers, as opposed to the current gen, which always waits for the developer to say, I want to start, and therefore is a little bit more laggy. So we've actually continued to reduce that latency basically down to near zero. Does that make sense?
Yeah.
Cool. Anybody else? The heat in the room is so oppressive. I feel like I'm melting. This thing blows nothing but hot air out. Any other questions? What do you guys think? Does this make some sense? Seem completely crazy? Halfway between? Nothing, eh? All right. Okay, well, if you do have questions, you didn't want to ask them in the group, I will hang out here.